Twins, identical twins, might offer a clue as to why some normal elderly people do better than others. Both from the same egg and sperm, sharing features as specific as blood type and fingerprints. Shouldn't they perform identically in old age? The answer is no. Clearly, some age faster than others. Is it because one had a different lifestyle, a different diet, or made different demands on the mind? The answer to that question may come from Sweden, where birth records of twins, those reared together as well as those separated at birth, have been maintained for several centuries. At the Karolinska Institute, Nancy Peterson is conducting a remarkable exploration into the relationship between genes and environment in human aging.
The importance of the study of separated twins in conjunction with twins reared together is that it can give us a better idea about whether or not genetic factors over our whole lifetime, from being early environment, adolescent environment, adult environment, are important for the differences we see in people as they grow old.
Identical twins, Dan and Bo, are 71 years old. They were raised together until age 20, and since then they have kept very close. What then accounts for the differences that have recently begun to widen between each one's ability to remember, to perceive, to understand? If both once performed at similar levels of competence, why suddenly, at age 71, does Bo have trouble with a simple puzzle like this? While in the next room, his brother is undaunted by a much more complex task.
Information from hundreds of sets of twins has been assembled in Sweden, and a cooperative team of researchers headed by Dr. Gerald McClure of Pennsylvania State University has been analyzing the effects of aging on a number of physical and cognitive abilities.
This project is the most exciting thing that I've ever encountered in my research career. One of the most salient facts about the aging process is that people do it differently. Some are able to survive with their functional capabilities intact until a ripe old age. Others start showing signs of debility and decline in middle age and rapidly go downhill. And our principal concern is with getting a handle on why these individual differences exist. At one time, it was possible to think that our genes were all present at birth and we were simply an unfolding of that initial genetic complement. In recent years, the exciting results in molecular genetics have shown us that instead we should view the genetic system as a dynamic process with genes being turned on and genes being turned off and genes being sometimes turned on and off for short periods of time. This gives us a different conception of the role of heredity and environment in an unfolding individual lifetime. It offers us the possibility that we'll be able to identify points of intervention both in the unfolding genetic system and in the unfolding environmental system that will allow us to promote successful aging in an increasingly large percentage of the population.
The differences emerging between Bo and Dan must be the result of the interaction between specific events at the level of single genes and the environment. In other words, not all mental decline in old age is the result of a genetic blueprint.
In a more recent study on the effects of aging on cognitive abilities, Dr. McClure is focused on yet another group of adults, identical twins and fraternal twins, 80 years old and beyond. Identical twins develop from a single fertilized egg that splits in two, thereby resulting in two individuals genetically identical and of the same sex. Fraternal twins, on the other hand, develop from two separate eggs, and although they share a similar in utero environment, are no more similar genetically than ordinary siblings. They may be of the same or of the opposite sex. In this figure, we see the correlations between the scores on the cognitive measures that monozygotic twins obtained compared to the scores of their monozygotic twin siblings. In addition, we see the correlations between the scores on the cognitive measures that dizygotic twins obtained compared to the scores of their dizygotic twin siblings. It is clear that the cognitive scores of the monozygotic twins were more similar than the scores of the dizygotic twins. This difference was particularly apparent in general intellectual functioning, but was also evident to some degree in verbal ability, speed of processing, memory, and spatial ability, respectively. This figure illustrates that the proportion of variance for cognitive ability for identical twins can be best understood as the contribution of two critical factors: genetics and non-shared environmental experiences. Shared environmental experiences were less important in determining this outcome. Comparing genetics and shared environmental experiences, genetics play the most critical role in determining individual differences in cognitive ability into old age. But non-shared environmental influences are also very important.
It should be noted that the components of variance that I've been describing, the results of these analyses that speak about a genetic component of variability and different kinds of environmental components of variability, all are describing anonymous influences. And we're getting increasingly happy with the accuracy of the descriptions that we and other investigators in this field are providing. We feel that we're really coming to get a picture of how important relatively genetic factors and environmental factors of these different sorts are at different stages of advancing age. The exciting prospect for the future is going to be to use this as a foundation, or building blocks, to begin to study the individual affective factors so that we aspire in the future to look into that component of individually experienced non-shared environmental influences and to say, what were these individual environmental influences that account for individuality in the aging process? And we want to be able to go into the shared environmental influences and say, what were they specifically? Was it shared nutritional background? Was it shared disease history? Was it shared educational history? Was it shared family rearing practices? And we know a lot about the factors that may be involved here. The optimal way of studying it, we believe, will be in the context of a study like this that is also genetically informative. Now, the prospects of going into that genetic compartment that is filled with, we don't know how many genes, we don't know where they are, we don't know where they're located, we don't know what they do at the present time, but the real challenge for the future is to be going into that compartment and trying to find out where they are. And the prospects of being able to do that are increasing at a geometric rate as a function of the dramatic findings of the Human Genome Project. Increasingly, we will be able to speak about specific genes in the sense that we know what the gene is and what it does. And increasingly, we're going to be able at least to identify the chromosomal address of a gene. We might not know quite what it is yet or what it does, but we're going to be able to say it's in such and such a place on chromosome 12, or it's in such and such a place on chromosome 4, and somewhere in there there's a gene that is influencing variability in memory function, in general cognitive ability, and so on. And this is going to be the exciting challenge for the future.